Hi, in this video, we're going to express this given trinomial in factored form, and note that it says that it's a perfect square trinomial. This means that we're going to factor it the same way we always do, but that the final answer is going to have a perfect square in it. So let's take a look. First thing we want to do is see, is there anything that can be pulled out of all three terms? Now I look at this and I am going to start with the numbers, right? So I have a 5, a negative 30, and a 45. Well, I can pull a 5 out of all three of those things. Now I have to look at my variables as well. So the t's, I have a t squared, a t, and then no t. So there's no way to factor out t's from this. However, because I have a w, w squared, and w cubed, I could pull a w out of all three. When I do that, I'm going to be left with a t squared, then a minus 6tw, and then a plus 9w squared. From here, we can use our AC method to factor. Now this may look a little strange because we have the two variables, but what you want to do is you just want to pick one of the variables to be your main one. Since our first term has that t squared in it, I'm going to say t squared is our main variable and everything else is going to be our coefficient. So again, this is kind of an odd one, but you're going to just basically look at everything that doesn't have the t. So I'm going to just highlight all the parts that aren't t, that are inside the parentheses. So you can kind of see what I mean. So what we have here is that what's in front of t squared is really a 1. So our a is equal to 1. Our b is going to be negative 6 and w. And our c is going to be 9w squared. So again, this looks a little weird because we have the two variables, but don't freak out. It's okay. Because when we do our a times c, we're still multiplying our values. 1 times 9w squared gives me 9w squared. Our b is negative 6w. Now, we're going to treat this as if it were a 9 and a negative 6 for a moment. What two numbers multiply to 9 and add to negative 6? Well, if two numbers multiply to a positive but add to a negative, then we know that they are both negative numbers. So we could do negative 1 times negative 9 or negative 3 times negative 3. Those are the only pairs that we have. And we see negative 3 and negative 3 are the ones that add up to negative 6. Then we remember that this is 9w squared. So each of our pieces would also have to have a w. So what we're having here is we have negative 3w and negative 3w are how we're going to split up that middle term. Now, coming back over here, remember we're carrying this 5w that we'd already pulled out on the outside here. And then we're going to break apart the middle term for what is still left inside. So we have the t squared still, and we have the plus 9w squared still. But then we are breaking that middle term up into minus 3wt minus 3wt. So that allows us to now factor by grouping. So we carry down our 5w still. Never forget to bring that down. Always write it for every step. And then when I look at my first two terms, t squared and minus 3wt, I see I can pull a t out of both. And that leaves me with t minus 3w inside those parentheses. For my second set of terms, I'm trying to find the greatest common factor for negative 3wt and 9w squared. I can pull a 3 and a w out of both. I'm also going to pull a negative out so that the first term inside the parentheses becomes a positive. So if I do minus 3w, like that, When I pull that out, I end up with t minus 3w inside the parentheses. Now, another thing that you'll notice here is that when we did that, we were left with two things that matched. So we have this t minus 3w happens twice. And we also have what's left over is this t and a minus 3w. Because we have t minus 3w twice in our answer, we'll write our final answer in this format. 5w times t minus 3w squared. And this is why the question says to express a perfect square trinomial in factored form is because our final answer has that perfect square.